All right, we talked about it earlier this year, and we're working with it again in this section and this week. So, inverse variation. All right, we're going to say here that as an equation, the following are examples of each. First, we got direct variation. In direct variation, y is going to be equal to k times x. Or if you were to divide both sides by x, y divided by x will equal k. All right, where k is your constant. And not equal to 0. So, meaning if you were given a table of values, and in your table of values, every time you divided y by x, you got the same thing. All right. So if we took 10, we divided it by 5, all right, what would your k be? Your k would be 2, right? And if we took 12 and divided it by 6, k would be 2. All right, so if you're given a table of values and you're asked if the table of values represented a direct or an inverse variation, you could start off by dividing all the y's by the x's, and if you got the same thing every time, then the data would represent a direct variation. And if you had to write a equation to represent that variation, your equation would be that y is always equal to 2 times x. All right, that's using this format right here. So when you can divide y by x and get the same value every time, it's considered direct variation. Now, inverse variation. Equations that are an inverse variation would be in the form of x times y is equal to k, or a constant. Y equals k divided by x. Or you can say that x is equal to k divided by y. And again, where k is your constant and it's not equal to 0. So if you were given a table of values, and you were asked, does the table of values represent a direct variation, an inverse variation, or neither? And your data was 215, 4, 7.5, 10 and 3, 15 and 2. Well, the last time we found k each time, we found our k by multiplying x times y. All right? In this case, if you multiply 2 times 15, I'm sorry, the last time we got our k by dividing y by x. All right, y divided by x equal 2. If you look at this data, if we multiplied this data, 5 times 10 would be 50, 6 times 12 is 72. You don't have a constant each time. All right, so if you multiply them and there's no constant product, well, then try dividing them. If you divide them and there's a constant, well, then it's a direct variation. Now, if you multiply them all, or let's talk about inverse first. So 15 divided by 2 is like 7.5. And 7.5 divided by 4 is not 7.5, is it? All right. So dividing y by x doesn't give you a constant. In this case, multiplying x times y gives you a constant, because 2 times 15 is 30. And 4 times 7.5 is 30. And the pattern continues. 10 times 3 is 30. And 15 times 2 is 30. So this data has a constant of 30. So if you were asked to write this equation, all right, this would be an example of inverse variation. So if this data varies inversely, then you're going to use one of these 3 equations, or the form of one of these 3 equations. So I'm just going to use this first one right here. If we had to write an equation to represent this data, we would just say that x times y is equal to 30. So if x times y equals the same thing each time, you've got inverse variation. If y divided by x is the same for all the data, then you have a direct variation. If neither of those happen, all right, if you divide all the data and you don't get a constant, and then you multiply all the data and you don't get a constant, well, then neither situation exists. Okay, so you don't have direct variation and you don't have inverse variation. So that's the first part of your assignment today. In the second part of your assignment, you're going to be told that suppose x and y vary inversely. Right? And inverse variation means x times y equals a constant, right? X times y equals a constant. So x and y vary inversely, and x equals 4 when y equals 12. write an equation and graph the data. All right, so if you're told that they vary inversely, then your x times your y equals this constant. So we're going to take 4 times 12, and it's equal to 48. All right, so your constant is 48. So your equation is going to be xy equals 48. Now, in order to graph this, we're just going to do a table of values, and you can pick about 4 points. Looks like they did 6 points. So let's try 6 points. So if we do it a XY table, and I'm going to use, let's use 3 as an X. We got 4, 6, 8. And all I'm doing is I'm using all the factors that'll go into 48 evenly. Okay. 3 times 16 equals 48. 4 times 12 equals 48. 6 times 8, 8 times 6. We can do 12 as an input again, so it'd be 12 and 4. And we can also do 16 for X and 3 for Y. So then you're just going to sketch a coordinate plane. And since all your data is positive, you only need quadrant 1. So here's X's and here's Y's. So we're going to plot 316. So I'm going to go 3, 16. 4, 12. 4 and about 12. 6 and 8. So 3, probably 6 and 8. And then we would have 8 and 6. 12. 4. And then we got 16 and 3. So if we plot all of this data, all right, we got 6 and 8 right here. We got 8 and 6. We got 12 and 4. And 3 and 16. I'm sorry, 16 and 3. So here's your graph of this inverse variation. It kind of creates this curve. This red one's a little bit off right here, so we need this to be. So here's kind of a sketch of this graph of this data. All right, you're going to see this curve that's going to stay in quadrant 1. It's never going to touch the x-axis, and it's never going to touch the y-axis. Can you all handle that? Write an equation. Or look at the data, determine if it's inverse, direct, or neither. Write an equation. Sketch a graph. Well, you know that it's direct or inverse by, if you're given the data, right? If you multiply x times y, and you get the same thing every time in the data, then look right here. If x times y is the same every time, then it's inverse. Okay? Now, you see in this case, x times y is not the same, is it? X times y would be 50. 6 times 12 would be 72. It's not the same, is it? So if x times y is not the same every time, it's not inverse, and it's direct. And when it's direct variation, then y divided by x equals the same thing every time. All right, so see how you got 10 divided by 5 is 2. 12 divided by 6 is 2. So when y divided by x equals the same thing every time, you got direct. When y times x equals the same thing every time, you've got inverse. If neither of those things happen, then you have neither. All right? If it is direct or inverse, then go ahead and graph it. Okay? If they only give you a couple of data points, then you choose the other data points. Here's what I mean. Let's say that x and y vary inversely. And x equals 8 when y equals -7. All right, so what models, or write an equation, and graph. So if they're telling you that they vary inversely, if they're telling you that it's inverse variation, then your equation is going to be x times y equals k. So watch, we go here. They're telling you that your x times your y is equal to a constant. So we take 8 times -7, and we get -56. All right. So here's my x times the y equal to the k. So now the equation is going to be x times y equals -56. So whatever data points you pick, you've got to multiply to -56. So if you kind of start, if you start with, here's an XY table. Whatever we put in this table has to multiply to -56, right? So they gave an 8 and a -7. What else multiplies to -56? All right, you can do a 7 and a -8, right? Say that again. You can go +2 and -28. And what else could you do? Couldn't you do -28 and +2? Anything else that goes to 56? 4 goes, doesn't it? 4 and 14. So 4 and -14. And you can also go -14 and +4. So there's 6 data points, right? So now look at our x's. Our x's got to go from +2 to -28. And our y's got to go from negative. All right, so we're going to be looking more like this now. right? So we got a 2, negative 28. So maybe 2 and negative 28. 4, negative 14. 7, negative 8. 8, negative 7. Negative 14, 4. And then negative 28 and 2. So here's the negative 28, 2. Oh, yeah, my bad. Good call. Give me my eraser back. So we got this 2 right here and the 4. All right, so now we can plot it. So we got 2, negative 28. 2, negative 28, that's this one. 4, negative 14. 7, negative 8. 8, negative 7. You're going to see it. Watch. Well, I think I know what you're wrinkling your forehead about. Negative 14, 4. Negative 28, 2. See it? It's kind of looking crazy, right? Now, remember this one here? Made this curve. Watch if we put some, see how this one's starting to turn right here? It's gonna make this curve. What if we went out here bigger? Okay. Like if this was a positive 14, what would this be? Yeah, the negative 4. And if we did a positive 28, we could do a negative 2, right? And see how those would be out here towards the far right of this graph. Probably out here somewhere. Still would never touch the x-axis. This is the other portion of the same graph. Okay. Look, if we go, like if we use these same inputs, but we went negative 7, we need an 8, right? And negative 8, we need the 7. You see what would start happening up here? If you went negative 7 and 8, you know, negative 7, 8 would probably be about here. If you did your negative 8, 7, here's what you're going to get up top. So this is the other portion of the graph. All right, so if you start to see a little bit of a crazier graph like that, where you got like 4 data points in one quadrant and 2 more in the other, and you want to go ahead and finish the graph, just go ahead and put in more data. All right. Could have done the same thing with this other graph to get the data that goes down here in quadrant 3. So, and you can see what happens. All of this data from this graph worked, right? 316. So they all had to equal positive 48. Wouldn't the same set of data work over here? Watch if we did this. but just made everything negative, wouldn't negative 3 and negative 16 give you positive 48? And so would negative 4 and negative 12 and negative 6 and negative 8. And if we just negated everything here, we would have all negative coordinates, agreed? And wouldn't those all get plotted down here? All negative, negative. You would have this same curve, but it would be, down here somewhere. Okay? All right, very good. All right, so your assignment for today, page 503. Six through 18. Six through 18. That's going in the basket. Or if you're an e-learner, you are emailing a picture of your assignment upon completion. You e-learners, this page has been uploaded to the resources tab, so it's there for you to go do. If you don't have any questions, you're excused from the Zoom meeting at this time. The rest of you, as soon as I close this meeting, I will upload, or I will put that page up on the wall for you.